Hello, I'm going to talk about 5G Open RAN innovation in the context of small cells, this is a small cell event, and in the context of silicon systems on chip. So during the course of this presentation, we'll look at the Open RAN supply chain and what the requirements are, and then the challenges around that. We're looking at the flexibility that's required in small cells. And then we'll look at how you can build a small cell system on chip to take into account this flexibility and still get something that's optimized. So some background here to start off with. Something to realize is the incumbent vendors, and there are two of them here, Ericsson and Nokia, Huawei will be another one, have their own SoCs, systems on chip, which are optimized for the application. And by optimized for the application, it's a high performance that they will provide in the application. And they're also optimized for power, and power dissipation being really important, whether you're in a data center, but obviously, especially if you're up a mast or in some low power situation, maybe for indoor deployment of a small cell. Now, silicon cost, whatever you say, has a fundamental limitation. I've stated it here as $200 billion per square mile. And that's partly done to obfuscate, so that I'm not actually quoting a price per wafer. There are other factors there as well. It's yield. Big chips will have a lower yield. You've got to package it. You've got to test it. But whatever silicon you're using, it's fundamentally going to have the same basis. It's probably the same wafer fab that's being used. So if you use chips which are unoptimized for the application, they're more general purpose, and this is something we'll get onto later on. It's going to be a higher power because you've got lots more transistors than you need, all burning power, and a higher fundamental cost. So the conclusion we come to here is that if you're going to compete with incumbent vendors, new entrants into the market are going to need some silicon, they're going to need chips to base their products on. So what are the challenges around developing chips for Open RAN small cells? Well, it's the flexibility. I'm going to identify three types of flexibility here. The first is spectrum flexibility. So I've used here a US example. This is the CBRS band, and there are a variety of things you can do here. The top example there is a single operator who maybe wants to maximize the spectrum they've got available. Now, depending on the location and dependent on the day even, an operator may have different spectrum all across this band, and they want to aggregate it together and be able to use it. So for a small cell using the CBRS band, you want to be able to do this efficiently. The second example there is a neutral host example. So this could be a neutral host operator supplying services to several other operators from the same small cell. The next example I want to use actually is something more that we'd be looking at providing 4G and 5G in the same spectrum, in the same small cell. The example here is fairly typical of many parts of the world. A LTE to support legacy users in, say, band 1 or band 3, C band, band N77, 5G NR. And also there's a likelihood you might want to migrate some of that spectrum that was initially used for LTE to 5G NR in the future. And the final thing I'll talk about here is performance flexibility. So we have a picture here, which comes from a small cell forum document in that, showing the various functions that you have in a small cell. So the throughput is governed by fundamentally the total bandwidth you have available, which is the number of antennas plus the bandwidth per antenna. This is dimensioned across the small cell, and it's trade-off against how much bandwidth you're going to allow for an individual carrier, and multi-band operation, how many bands you're actually supporting within the same small cell. And examples here could be in the same architecture. You have a single band, 8T, 8R. You would have a single band 44R with some carrier aggregation. That might be, say, going from a 200 megahertz bandwidth rather than 100 megahertz bandwidth. Or you have dual band 44R, quad band 2T2R, or some combination of any of those. And there are challenges to be able to actually address this within one single design and still remain efficient. There's another dimension here, transmission power. But transmission power is largely governed by the front end. There are digital functions there like digital pre-distortion, but digital pre-distortion is pretty standard in all small cells at the moment these days. It's actually required to meet 3GPP specs, except the very lowest of power outputs. The third example of flexibility I want to address here is architectural flexibility. At Picocom, we're seeing that people are wanting to have small cells with a variety of different splits. Split 8 is still being used in some geographies where they want to get the absolute minimum cost RU, and there's legacy infrastructure there. Split 7.2 is a lot more common, and this is particularly in buildings where there's quite a density of small cells, and it makes sense to aggregate processing for the EU. Split 6 provides efficiency of backhaul. It provides a common MAC layer, but where maybe you don't have quite such a density of small cells, and the throughput is actually greatly reduced there compared to split 7.2 in the backhaul or front haul. And then split 2 or even fully integrated small cells are something which a lot of people still like. It actually gives you ease of deployment there. You buy core and CU, and you can deploy these very easily. But it's all about getting the radios, the right type of radios where you need them. And many operators want to have the flexibility of deploying all of these, not necessarily exactly the same hardware, but with hardware based around the same architecture. So can you actually build this into the same SoC? Well, this diagram here shows fundamentally at the bottom, underlying everything there, we have some silicon transistors. And going up the left-hand side there, we see they can be like general purpose gates that can be used for general purpose hardware, which could be optimized for task. You could have some digital signal processors or vector processors, which are still somewhat optimized, but they have their flexibility where you need it. And then you get to general purpose processors. And at the bottom there, you're going to get the lowest power consumption for an application if you build things out of general purpose transistors. And you need to do that for certain functions like channel coding and decoding, forward error correction. That's very inefficient if you start doing from general purpose processors. There are also things there like the interface. I mean, who would do Ethernet MAC header processing on a general purpose processor? You do that in some sort of dedicated hardware. Then there are things like channel equalization, where you need some flexibility there, flexibility to do different algorithms. But if you start doing that all in general purpose processors or even in digital signal processors, your silicon area is going to expand greatly. But there are things there like the control here of the layer 1, APIs, where you need to be doing that in some general purpose processors. And the key is to get the right blend here of what you're doing in more dedicated hardware, what you're doing in things that are somewhat configurable, and what is you're doing it in a general purpose sort of way, so that you can meet all those flexibility requirements we've been talking about. So the ideal situation here is you have the one-to-many. You have one SoC or a small number. You have software, which is configurable. It's used to configure those SoCs. And you can then use the Open RAN interface specifications from those. And you can get out a rich variety of DUs and RUs at the other end that can be deployed in this wide variety of flexible scenarios. So if I just tie all that together, I think we've demonstrated here that Open RAN needs chips. Otherwise, it's not going to be competitive with incumbent silicon. And this is essential for competitive vendors, new vendors into the market, which is actually what many mobile operators, private operators, are wanting to see. Open RAN small cells need flexibility. And that is just something we're seeing, that small cells need a lot more flexibility than macro cells. One key example there is that macro cells you can have 2 macro cells for 2 operators quite easily, rather than 1 macro cell that can address the requirements of multiple operators. So we have shown here that actually you can do a silicon architecture with the right trade-offs that can actually achieve in the 5-layer processing, the layer 1, something that meets these flexibility requirements, still within the right power envelope and the right price point to enable small cells for 4G and 5G. So with that, thank you very much.
Good day to all. My name is George Aguilera, and I will be talking about deploying an open and neutrally hosted private and public small cell network. Crown Castle is a neutral host provider in the United States. I recall hearing we had a presence in London many years ago. We also had some towers in Australia until we sold that portion off so we can later buy fiber assets. And in the United States, we have over 40,000 towers, 80,000 route miles of fiber, 900 plus connected data centers, points of presence and co-location sites, 47,000 on-net buildings with more than 50 cloud access points, a lot of small cells on air or under contract, about 5,000 employees, and we've been in business for more than 25 years. We've worked since 1994. We've worked around the United States to build and maintain the infrastructure behind the world's most revolutionary technologies. And our portfolio is pretty diverse. With it, we bring information, ideas, and innovations to people and businesses that need them. Since Crown Castle is a real estate investment trust, 90% or so of our assets have been leasable space, or they have to be leasable space rather. Our tower leasing business is simple, yet can be challenging to implement due to many jurisdictions in which we operate and due to the varying needs of network operators, and now enterprise customers as well. I recall when I came on board in 2011 that we had our small cells team well on the way. And therefore, we have very bright people in technology. Our expertise in RF planning, deployment, and operations is also we can lease more of our growing asset portfolio. Though we care to an extent, we generally do not really care which technology we need to learn to conduct our business. And here's some recent statistics. Well, not so recent, but their predictions through 2025. There you can see that the little red line, the red band, is actually the CBRS, which is the current deployment that I'm talking. I will be talking about, and there is a projected growth. It's and this is actually for outdoors, although our the projected growth is for outdoors. I think it's a little conservative. I think it'll probably grow wider than that. And the presentation is, or the case that we're talking about is routing. And I do want to talk a little bit about what the Small Cell Forum membership, how it benefits Crown Castle and myself. We want to know what people are doing, what businesses or technology models work elsewhere in the world. We want to share and learn and also, interchange perspectives from telecoms, manufacturers, developers, neutral hosts, enterprise-focused service providers, mobile operators. I think that specification started in the UK many years ago, and then in the United States we embraced them. So I see something similar happening with JOTS, hopefully, and we'll talk about that a little more later. But I think we can all agree that sharing of ideas is valuable, and that's what those are the benefits to Crown Castle. Now going to from the small cell forum to the high level business case, we looked for a certain set of criteria or characteristics in what I like to call a customer partner. And some of them were that they they would own or manage premium properties, so they would have the funds. They have a strong IT resource capability. They're curious and willing to trial a private CBRS network, even though there weren't too many CBRS native devices out there at the time. The customer partner is willing to work also to deliver, or for us to deliver 5G in the future, not necessarily today. I'm going to focus on 345 Park Avenue, which is a ritzy place in Manhattan, and it's part of the routing management company. And they own several buildings in downtown Manhattan. And so we also, in the development of, we were also looking for any OEM partners to be just as progressive as the customer partner. And they needed to be experienced with operators in the United States, experienced in private network deployments, provide a cost-effective solution. That's always important. And have a software upgradable product set from 4G to 5G. And of course, very responsive to our neutral host needs as well. So digging a little bit into our customer partner was very valuable. Like I said, I'm focusing on 345 Park Avenue, which is a building with 44 floors. Routing also has in that building very high value tenants like the NFL headquarters, KPMG, and Blackstone Company, and actually maybe a couple of consulates as well. So along with device availability, we needed to test and identify additional features needed to satisfy our customer partner, its enterprise tenants and operators, of course. We actually are on our second OEM for routing, as the first one did not work out as a neutral host provider. It wasn't flexible enough, didn't work out for us. And then the Open RAN 7.2x split is what the OEM provided, is what we were looking at in our hosting model presence nearby and on the premises. And at the point of presence, we put in our centralized unit. And so we found that that could be an aggregation point, that distributes to multiple buildings, which Rudin also has. And then we did some use case testing and optimization in the lobby and the mezzanine levels. It was during the COVID-19 pandemic, and it was important to incorporate health and safety protocols. And so that was their interest. Operators were also, although we sort of knew what operators wanted, they always need to improve their in-building coverage. where they're missing. So some of us debate what drives the need for a private network and edge data centers. I've often heard that low latency is the driver. Well, that may be true. To date, I have seen the concern for data security, data not going off the enterprise has the driver for routing. It was really about security. Their building management system integrates with all types of IoT. Their analytics and machine learning artificial intelligence platform has demonstrated that it can save power in the long run and in response to emergent events. Enterprise tenants may want similar capabilities for their office operations as well. And since the buildings have multiple tenants, there are very few common areas where even Wi-Fi access points could be mounted. Even then, sometimes we could only mount our equipment in small janitorial closets. The CBRS band, even at the power levels that are much lower than public 4G or 5G networks, provided enough coverage for the targeted areas. Operators, of course, want to extend their 5 bars of service into high-value buildings, offload capacity from nearby towers. After all, Lower Manhattan is a very crowded place. And also upper floors often get very little signal. So we can provide that, for them. Then the solution. Our solution was to deliver a network that is future-proof for 5G and beyond to address the use cases such as integration with the building management system or operating system, package delivery tracking while inside the building, occupancy and dwell time data for COVID-19, as well as tracking and taking action as needed for elevator and wait times. Also for performance and scalability, we placed the distributed units locally on the premises for security as well as for performance. We placed the centralized unit or units in our edge data center to support multiple buildings and customers, as well as for scalability. Here is where we benefited greatly from having a customer partner with strong IT resources, an existing building operating system, and a willingness to test with us. For our MNO neutral host role, we required a solution that supports multiple carriers and low cost, of course. Our solution provides in-building wiring for future mobile operators, though the disaggregated nature of the network required more fiber than we're used to installing. We installed the fiber and fiber paths to make that accommodation. Yeah. The neutral host platform. The hosting model we planned to use outlines our roles, that what is shared and what is not shared. Here, the colocation center is the edge data center or nearby point of presence. It is also important to note that our demarcation to the MNOs does not include their transport. We pretty much took care of all other aspects, including fiber to the edge data center. I should also make a distinction that we provide the servers and the radio software, but both are not the same. So we won't group them as the same. Besides what is located where, the operations and management aspects will come more into play as we get more customers and we provide more value-added services. The architecture, actually, I took this diagram, the architecture diagram, out of the SCF 245 document and modified it to represent our deployed network. Therefore, for more details, see the SCF 245, which is being published this week, actually. One point to note about this diagram is that the backhaul branches out to respective MNOs within New York and does not go through to our regional data center, which is actually in Pennsylvania. Those are the arrows that are behind the management and security box. They're in different locations. Here, what shows in green is what we host. The orange is the private network. Technically, it is a single private wireless network, but APNs are used to route different routing profiles and tenants to different parts of the same overall subnetwork or subnetworks. On the public network side, we use pass-through of MNO PLMN IDs through the MOCN gateway for subscribers to connect to each respective mobile or public network. The SAS-DP, the SAS-DP, is the Spectrum Access Service domain proxy function for CBRS, which is a required component for one to obtain a spectrum access grants to channels under CBRS. Some of the lessons learned. We learned a lot, but I can't really talk about all of them because we don't have clearance. As it often is the case, expectations are not necessarily what you experience. However, we do not know what we do not know until we deploy it, and then we learn a lot. Each tenant had a different timeline for implementing the network. Excuse me. In some cases, it took time for each tenant to come around and see the benefit of having a private network. And therefore, enterprise tenant approvals can affect the deployment timeline. There are also many beautiful marble lobbies and mezzanines in New York City, and some appear to be priceless, especially on Park Avenue. So we had to be very careful where we manage the radios, which come in different sizes, not too many varieties though. But they cannot always be tucked away so far as to render them ineffective. Therefore, building approvals for antenna mounting and stealthing at times require repeated mock-ups and walkthroughs. Neutral hosting can be complicated where manageable mechanisms are needed to support capacity sharing and allocation, as well as coordination for each MNO to bring their own tracking area codes. Tags can be tricky. The way the paging system is designed in LTE and 5G is to find the UE by using a tag. However, if something goes wrong, users may end up being locked out from accessing the network for as much as several hours. Each MNO selects its own tags. Therefore, we needed to look at how it would work with a shared band, CBRS again. We looked at a couple of options, one is potentially using a TAC with a shared band. Yes, a shared TAC, but MNOs would not necessarily come to an agreement on that. And so that was fraught with issues. Or we can use a pass-through of existing tags. And in either case, some software development needed to be completed before we can make each one or the other or each one work. Provisioning interfaces also needed to be fairly mature when deploying many radios at a time. You can't really do a command line easily. It has to be something where you can upload a lot of components at a time, a lot of radios, and provision them. The red alarms needed to be identified as well. And many or some of them may require integration work to get a good flow going with our network operations center. Then we thought about, because we own the radio access network, are we responsible for emergency services? Fortunately, public operators manage their own emergency services like the E911. Then what about private networks? We are aware that new regulations are coming regarding higher resolution location reporting. However, the Federal Communications Commission regulations are still evolving, and we should keep an eye on them in case we become more responsible in the future. We have laboratories in which we tested and we're able to change configurations and validate requirements and our ability to meet them as well. We're able to conduct tests on roaming and MOCN configurations as we search for the best fit for all of us. We cooperated with MNOs to validate operator connectivity in different configurations without impacting their commercial traffic. So in summary, we provided for future-proof wireless network with faster speeds and better user experience. The Open RAN solution we use will lead to lower total cost of ownership and increased flexibility and scalability in operating the network. We developed a business case around a spectacular customer that is a private network first, but it is also capable of connecting wireless carriers in a new way that we can all work with. After all, we work with operators to build trust and iron out the wrinkles. We also provide them with a value proposition of extending their networks onto a platform we are happy to provide. We embrace innovation, and this is one way to promote it. Thank you.
Hello, good afternoon, and a very warm welcome. This is Keyur Brahmbhatt with Extenet Systems. Today, I'm going to talk about neutral host opportunities in venue-funded deployment market segment. Just by way of a quick introduction, I am with Extenet Systems CTO team. My responsibility is technology acquisition and product management. I've been associated with Small Cell Forum for a little around 7 years. So it's thank you for all the great partnership. Just to share a little bit background about Extenet Systems. Extenet Systems is the leading provider of converged communication infrastructure and services for advanced network connectivity, both indoor and outdoor. Founded in 2002, the company offers solutions that spans small cells and DAS, fiber, evolved packet core, and enterprise communication solutions. We are the largest independent owner and operator of distributed networks in North America. Extenet designs, builds, owns, and operates distributed networks. So, our competencies involve not only in the construction, but also support services and maintenance as a neutral host. Just by the way of quick facts, Extenet is a CPCN or has grants of authority in about 45 states. So that allows us the ability to deploy a telecom infrastructure in right of way. We have outdoor distributed networks in about 37 states. That includes 12 states with rural networks, and with more than 30,000 distributed network nodes, and with 500 plus distributed networks, we remain one of the largest distributed network service providers in North America. Our core competencies include network planning and design and implementation, real estate partnerships, municipal and regulatory focus, and network and field operations. With these core competencies, we are able to offer innovative network design and implementation services, provide proven carrier-grade operations, and offer flexible business and financial models to our customers. With these core capabilities and solutions, we are able to provide scalable service offerings to address outdoor and indoor communication needs for our customers. To cite some examples for Extenet deployments, these are all available in Extenet portal, but some of the marquee venues include Barclays Centers, Empire State Building, Miami Marlins, AT&T Stadium, Circuit of America, and just to highlight one of the venues is one of the customers is Illinois Valley Cellular. Extenet has a large base of fixed wireless and mobility customers. Illinois Cellular is one of the largest tier 3 mobility customers that provides a carrier-grade mobility services with full roaming with MNO partners, and that supports regulatory requirements. So as you can see, Extenet is able to offer converged communication infrastructure and services across multiple segments. So specifically coming to the topic of venue-funded deployment, so we can look at the in-building market. The US market is classified based on commercial building sizes. We can see the top tier, which is the buildings with floor space of 500,000 square feet and above. These are today served very well with neutral host DAS. And these are large buildings like stadiums, arenas, transportation hubs, and where this is where the service providers, which are our primary customers, and they become, they're willing to participate and become paying customers on a long-term basis. However, if you look at this middle tier, which is between 100,000 and 500,000 square feet, this is the tier market segment, which remains largely underserved or unserved. Right? There are more than 128,000 buildings with aggregated floor space of 23 billion square feet that remains underserved. So the opportunity really big in front of Extenet. Just to highlight, Extenet customer base includes primarily service providers, but we also serve a large portfolio of property owners and managers, enterprise customers, and municipal customers. So obviously, this middle tier becomes really, really important. And I'll show you in a minute, the profile of these customers in this category. So in this middle tier for a neutral host, then in the building of interest are commercially listed buildings, residential towers, business parks, healthcare facilities, which are like hospitals, and hotels and casinos and so on and so forth as hospitality type of venues. So the question really becomes that why all of a sudden these type of buildings are increasingly important. And the reason for that is in this space, traditionally the MNOs have not been willing to participate. However, today there is an increased need to provide connectivity in this space. Some of the reasons are obvious, but as you can see, for the building owners, the in-building connectivity, wireless connectivity, is sort of a fourth utility besides water, gas, and electricity. So for them, it is very important to provide reliable wireless connectivity, and also FCC is sort of making a regulatory requirement to provide reliable 911 services, and that too with enhanced location services for their users, and particularly when there is no other reliable way to make 911 call like a landline phone. With pandemic, the property owners are challenged to come up with business models that allows them to attract new leases, and also to renew the lease with the existing customers. So with that in mind, the opportunity really becomes, how can venue owner provide or build a network infrastructure that sort of future-proofs the needs for their own deployment needs, their enterprise tenants, as well as in future how to invite the MNOs as a paying customer at these sites. The question then becomes why Extenet, right? So as I had mentioned before, Extenet is a fiber-first company. So we have extremely dense fiber footprint in all major metro markets. That includes NFL cities, and there are quite a few of them. So this positions Extenet uniquely in terms of ensuring that all the enterprise and venue customers in those markets, they are able to bring in wireless connectivity on a converged infrastructure and then optimize TCO for them, particularly for this venue owners, so that they can become paying customers rather than relying on mobile network operators day one. So that's the immediate opportunity for Extenet, right? A leveraged shared digital communication infrastructure and make it ready for venue to become a paying customer, but then invite their enterprise customers, and so that venue owners can monetize with them, and also invite MNOs to become a participating customers. In terms of the deployment options, working closely with the forum and also looking at what other options are available in a standardized way, we have considered multi-operator small cells, active DAS, shared spectrum, CBR smoken, hosted Open RAN, and other architectures that we feel are relevant for shared multi-operator deployments. And so with that in mind and taking into consideration what our customer needs are, Extenet was able to issue an RFI last year. So that RFI, included the requirements for primarily considering what the venues are going to need today, and attract them with the best TCO network infrastructure solution. And also considering in mind, what the connectivity needs are for their enterprise tenants. So enterprise tenants are expected to require intelligent distributed networks that supports, the current trends such as, digital transformation, ultra low latency use cases, massive connectivity, and enhanced mobile support use cases, right? We have seen that even though the mobile network operators may not be eager to participate in the venue funded opportunities today or in this middle tier, they have invested very, very heavily in the 5G mid-band spectrum. So with about $100 billion gone into 5G network deployments and network spectrum, we are already seeing that MNOs are aggressively building this network, right? But ironically, more than 80% of data consumption is happening indoors, and more and more people are spending time indoors, and pandemic has sort of accelerated that trend. So the opportunity for MNOs is how to extend their massive capacity that they have purchased indoors, so that they can start monetizing it. So the network requirements in the RFP was comprehensive in short, right, covering the needs of venue owners and their enterprise tenants as well as MNOs. So the requirements covered full 280 megahertz of C-band spectrum, full 184 megahertz of band 41 spectrum, and full 150 megahertz of CBR spectrum, and also the mid-band spectrum that is required to support LTE for all major MNOs today. And the key was that the Extenet shared infrastructure design that allowed to support all these network requirements for these key customers and still get the best-in-class TCO. And Extenet has a large portfolio of qualified and strategic partners. So we were able to issue this RFP to study a qualified pool of qualified suppliers and ecosystem partners. And we were able to get an RFP response from them that allow us to compare these solutions side by side. And then the responses covered both small cells, licensed and unlicensed categories, as well as the neutral host DAS proposals. And the DAS proposals include traditional analog coax DAS, analog fiber to the antenna DAS, and as well as digital fiber to the antenna neutral host DAS solutions. So at the end of the day, for Extenet to offer the best-in-class TCO for the venue-funded opportunities, we had to compare, apples to apples between these vendor supplier solutions and identify, what solutions offer best-in-class TCO for us. And we actually came away with interesting observations. And to the likes of to the participants here, we're happy to notice that the licensed small cells today remains as the best-in-class TCO solution for neutral host multi-operator small cell LT connectivity. Unlicensed small cells also offers best-in-class TCO for the private network or a shared MOCN CBRS neutral host network. However, we noticed that 5G multi-operator small cells become a little bit cost prohibitive for these venue-funded opportunities, particularly when venue is an anchor tenant. Neutral host DAS offers the best solution for day one 4G and 5G public and private network in terms of the TCO. However, we also noticed some interesting observations in terms of technical merits and installation costs and operations based on the various types of the architectures within. So these observations, these responses allowed Extenet to define and create a proposal for the venue funded opportunities, a solution portfolio, if I can say. That offers best-in-class TCO for a future-ready shared infrastructure solution for the imminent venue deployments. So we're happy where what we have seen in terms of the solution portfolio, and we are eager to engage with our target customers. Already seeing a huge traction, particularly in the mid to high tier of the mid to high size building segments, which is 350,000 to 500,000 square feet in the middle tier, where day one 4G, 5G deployments are imminent. But we are also likely to see in the small to medium sized buildings how we can leverage the RFP response and to offer best-in-class TCO for venue opportunities. So with that, I will stop my presentation and open up for any questions that may be available from the participants. Thank you so much. Have a great day.
Hello, I'm Roger Galuban, Strategic Product Manager with Ericsson, and I'm here to talk to you about accelerating neutral host deployments in the US market. So let's talk about the excitement we're all going through because we're back to travel, back to airports, back on airplanes. Isn't it great that after the pandemic, we can all go visit with family members? Now business travel is starting to pick up again. We get to see our colleagues we've been missing for a while, unless you're one of the people that get stuck with flights being canceled. How frustrating can that be, right? And what happens here, when you get your flight canceled, where are you going to go? Well, most likely you're going to be stuck in the airport somewhere, and you're going to pull out one of these, your smartphone, and you're going to look at options. Do I book a hotel? Is there another flight I can take? But if it's during a holiday weekend, very likely you're traveling with family. Maybe your kids are with you. They are pulling out their smartphones and they are looking at social media, maybe downloading and trying to use a movie, unless the experience you get at an airport is subpar, not really what you would like to have. Isn't that so frustrating? And how many of us have gone through that now that we're back at traveling? What has happened over the last couple of years that it seems that service at airports actually gotten worse than what it was pre-pandemic? Well, it's not just because there are more passengers. It's also because our devices demand much more from those networks. We have higher resolution cameras, we have higher resolution screens. Some of the apps that in the past used to just be pictures, now they automatically play video as well, and ads and whatnot. So the demand on those networks has increased, and they have unfortunately not been able to keep up with the demand that we as consumers expect, right? So how do we address this? Well, we used to be able to address these problems in airports and venues, similar venues to airports, by using distributed active antenna systems. And they had been our sort of go-to neutral host solution, right? So you deploy one of those systems, you get radios from the various operators, and then you get signals serving customers from any of them. So perfect for 2G, maybe for 3G, starting to struggle with 4G, and now we come at a situation with 5G where a lot of these systems are crawling, and they can certainly not keep up with the demand. And upgrading them to be able to support some of the needs, some of the specific requirements of 5G is extremely expensive. So how do we do that? We need a simpler solution, because there is a need for us to start to catch up with devices are now demanding more from our networks. And the networks are just not there to provide that experience. Yeah, a lot of investment has happened on the outdoor macro network, and that's great. But now we need that experience indoors as well, right? So how do we accelerate that? We believe that a neutral host small cell solution is actually a much better alternative than how we have been trying to solve the problem for the last decade or so with the traditional distributed antenna system, or DAS. So let's look a little bit into the details of how that plays out. So here, the picture on the left, you see basically an architecture diagram at a very high level of an active DAS system, right? You have your main unit there in the middle. That is part of the shared equipment with the remote units and the antennas. That all sounds sort of okay, but then to the left, you have different operators bringing in different radios, right? In the early days of, say, 2G, maybe you had one radio with one band, SISO, the single input, single output, just one stream of data, right, flowing or signal flowing from that antenna to the device. And that was fine for a voice call, for an SMS. You ran out of capacity. Guess what? Well, I got another 10 or 20 megahertz on this other band. Let me just add another radio, right? So from one radio to two radios seemed to be okay. Well, out of capacity on that band, slap another radio in there. So another capacity growth, and more radios until you realize, oops, I'm out of spectrum. I don't have any more bands to add. How do I deal with that? Well, let's break out those single sector that I had. Now I'm going to duplicate that into two sectors. Well, two sectors not enough. Let's go to 8 sectors. 8 sectors not enough. Now you go to a venue like an NFL Super Bowl type of venue. You have 80 sectors or more. Think of the amount of radios you need, right, to support 80 sectors on 3, 4, 5, 6 bands, right? All of those doing 2x2 MIMO. In some instances, even 4x4 MIMO. It's a huge amount of equipment. But then there is another problem we add on top of that, and that is the fact that new spectrum came up now with 5G, right? Mid-band TDD spectrum has been available in many parts of the world. Usually in the US here, we call C-band, like that 3.5 range to 4 gigahertz range, in some markets to 3.3 to 4.2. Anyway, the point is, new spectrum, everybody at first thought, oh, great, I'm just going to go back to add some more radios and get more capacity in the active DAS, until you realize, oops, my coaxial infrastructure, it doesn't do any more than 2.3, 2.5, maybe 2.7 gigahertz. There is no way that I can support my 3.5 gigahertz spectrum and that. So you're talking about a massive now upgrade, rip and replace in some cases of a legacy active DAS to be able to bring that 5G experience in the buildings. And guess what? That's why a lot of us are frustrated in airports and other venues similar to that, because the cost is so high that it hasn't yet panned out. It hasn't yet happened in many venues that the 5G solution has been added to those legacy systems. So how do we address that? Well, with something that we call the neutral host small cells. What is different from a neutral host small cells to a traditional small cells that we used to have years ago? A traditional small cell is a great solution, but they typically would have 1 or 2 frequency bands and not enough power to support multiple operators transmitting their signals at the same time. That is what is new now with neutral host small cells. They have a lot more power. They have multiple frequency bands from the low band all the way to your C band, all the way to 4 gigahertz and even beyond. It's certainly possible. So imagine a solution like this with 4 frequency bands having sufficient power to deliver experience for 3 or 4 operators in your market. Now, instead of having multiple antennas, instead of having any coaxial cables at all, you significantly reduce that amount of equipment in your venue. There are no more radios and adding of bands 1, 2, 3, 4, 5, 6. It's just one unit that you mount in the ceiling and you bring in our good old friend, our Cat6A cable, right? The electrical IT like not coax, you plug it in the back, you get here data and power for the unit that is in the ceiling. It's really quite remarkable. And we have seen these deployments now start where you can lower the total cost of deploying these venues by 50% or so when it comes to the equipment part of the solution. So it's something that we believe can help all of us to accelerate the deployment of 5G and neutral host solutions into venues such as airports or hospitals or hotels, anywhere where you need that 5G experience. And it's just not quite there yet today. So let's look at some of the different ways that you can actually go and deploy this 5G network using small cells. And by the way, I say 5G because that's the new spectrum available and everybody is quite excited about bringing that experience with more spectrum, more gigabits per second on your devices, right? And greater capacity for those networks, more gigabytes or terabytes that you can serve per minute or per hour in the large amounts of users. So 2 models here, right? And before I start in these 2 models, let me talk about where we came from. We came from sharing antennas. That's primarily what a traditional distributed antenna system or DAS was all about, right? You distribute the antennas, but the rest of the equipment, each operator would have their layer, their separate radios, separate basebands, etc. Now, the first way of reducing cost is by sharing the radio, just as I was showing. Now you have a unit here, a shared small cell that all operators are transmitting their signal. And what is cool about this is that these are not locked into a particular feature or a particular radio access technology, such as 3G or 5G or LTE or NR. You can actually have all of those operating at the same time. So you could have operator A that is still transmitting 4G LTE, no problem. On the same frequency band, you could have operator B that maybe has decided, well, for that frequency band, I'm going to do spectrum sharing. So I'm going to transmit LTE and NR on that frequency at the same time. And the third operator can come on the same frequency and say, no, I've transitioned all of my traffic on that band to NR and I'm doing 5G NR only. Not a problem for a smart small cells, a neutral host small cell like this. You can have that mix and match of radio access technology at the same time on a shared small cells, shared radio unit. Here in this picture, we call it IRU or indoor radio unit that is serving as an aggregation point. All the basebands connect to that common radio unit, and then the signals get aggregated and then distributed over to the different small cells here represented by a radio dot that I was just holding in my hand, where you can see then that signal and that experience happening across the network, across the venue. Now, some markets don't yet have the ability to do that with basebands only, because if you look at a market like the United States, where Ericsson is a provider to all the major tier 1s, so of course in that market we can for sure transmit different basebands commonly connected to a radio unit, so that different signals are being shared across the indoor radio unit and the dot coming entirely from a digital infrastructure. In markets where other vendors might be providing service to a service provider, then an equipment from that other vendor can also participate. You bring in their radio, their RF source. There is a solution called Indoor Connect that translates their RF signal into digital signal that then goes into the shared infrastructure, radio unit and small cells, right? So of course, in this multi-vendor scenario today, it will cost a little bit more because you still need racks of radios, right, to transmit the signal and then convert it over to digital. On the structure above, where you're going directly from baseband into the radio and then into the small cell, then it's a significant cost savings as there's much less equipment in that scenario. I'm just going to add here that this is also a vision that you can imagine in the future, right, where we have now open interfaces going into these radios. Imagine this is a ORU, right, with the open RAN. So you can envision in the future where it will still be a digital signal coming into those open radio units, right, with the open interface, and then still providing all of those. What today is a dedicated physical baseband could now be sitting on a cloud infrastructure, a virtualized environment with our virtual DUs, right, that are already existing. So over time, we certainly see this migration over to a cloudification, right, a virtual RAN or cloud RAN approach. Now, let's talk about shared RAN, because this is where we can achieve the most benefit from a cost saving and equipment reduction. So now even the baseband unit is shared. So think about a couple of options here. There's what we call multi-operator core network, or MOCN. This is an approach that has been used in a number of countries around the world, in Asia, in Canada, in Europe as well. And so here, operators agree that they will share the baseband. Sometimes will be different markets. One will do on the east side of the country, the other one on the west side of the country, and vice versa. And so that way, the cost is reduced, and that same baseband is transmitting a couple of PLMN IDs, or 3, depending on a number of operators that are sharing that infrastructure, and back to their respective cores. Now, there might be some applications where you may want to have an isolated baseband, as you see on the bottom right. For example, you might have a baseband that is providing a private network service in that venue, right? So maybe that's separated, and then your license spectrum might be combined as per agreement between the different operators. So all of these models are possible with a neutral host small cells. It's really up to each market, each venue, what makes sense, what cost targets you're trying to meet, as well as what technology agreements exist across the service providers in a particular geographical area. So here are some examples of what we have done recently here in North America. We have the solution deployed in our smart campus in Texas, here in the US. Anyone who would come and visit the Ericsson campus will see that we have a shared small cells, and that is providing service no matter which cell phone or smartphone you're bringing into that building. You'll receive the signal and you have service that way in a shared environment. We also have large international airports where this solution is now starting to be designed and deployed. And I have to say that back in the day, we looked actually at solutions using the small cell per operator, and it was not as elegant, because you needed a lot of these to be able to support multiple operators and multiple frequencies. But now we're able to consolidate that into a single unit, which really makes it attractive for high capacity venues such as airports. Speaking of high capacity, I should add that adding capacity with a neutral host small cell is a very simple activity via software configuration. Unlike DAS, where you think about planning your sectors from the get-go, and if you need to add more sectors, typically that means more equipment. The same is not true with a neutral host small cell. You can actually configure how large or how small your cells are going to be over time. And if you need to add more cells, maybe split a cell because your capacity has really grown into a particular area of the venue, you go and do that via software configuration without the need of running or installing any new hardware. So that's another point that when considering a solution, especially thinking about it being future-proof to handle capacity, not just today, but 2, 3, 4, 5 years from now, it's certainly a solution that becomes quite attractive from that point of view. And then, of course, you look at solutions such as healthcare. We have that deployed in airports. We actually have deployed our solution in the stadium that will host the FIFA World Cup in Qatar later this year, in case any of you are football fans or soccer fans, whichever way you prefer to call it, feel free to go to Qatar. And if you look up in the ceiling, I'm pretty sure you might spot one of these neutral host small cells providing service to the operators in the region. As you come and maybe you roam on their networks, the service will be provided by this neutral host small cell. So in conclusion, right, customers expect 5G experience when they're indoors. We've made a lot of progress on the outdoor macro network, and we get frustrated when we go inside and don't get the same level of experience. So that's what we want. But venues, neutral host companies like tower companies and others, right, who play in this space, they are feeling really challenged how they're going to modernize the legacy investment they've made in active DAS. Often it means a complete rip and replace, and that will be too slow, will take too much time, cost too much. There's just no end to the CapEx funding that is required for this. Well, we claim that instead of using that CapEx funding to do one venue, you take that funding and you do 2, 3, maybe even 4 venues, depending on the total cost and your targets of for capacity and experience in these same venues, but instead going with the neutral host small cells that are built for 5G and with the ability of being upgraded in the future to support future needs, whether it's 5G advanced or 6G and beyond. So it's a wrap up for me for this presentation. A big thanks to the Small Cell Forum for organizing this virtual event for those of us who sit here in the US, and I hope you enjoy the rest of your virtual summit. Thank you.
Hello, everyone. My name is Vikas Dixit, and I am working with Reliance Keyur and also representing into the various work streams inside the Small Cell Forum. And today I will be hosting a session related to the Open LAN and the neutral host for accelerating the 5G deployment. So we have a very elite panel here, ranging from the solution provider to the cell providers and also from the deployment. So what I will ask to give a little bit of introduction of yourself, and then we'll start the session. So Eugina, please.
Oh, thank you very much. Thank you for having me here. Eugina Jordan with Parallel Wireless. I'm VP of Marketing for Parallel Wireless, and Parallel Wireless is the company that started Open RAN movement for different use cases, macro, outdoor, and private networks as well. Thank you for having me here.
Thanks, Eugina. Keyur?
Hello, everybody. This is Keyur Brahmbhatt. I am with Extenet Systems. My role here is Director of Technology Acquisition and Product Management. So I'm responsible for strategic vendor partnerships, vendor qualification, product evaluation, and owning product roadmap. I've been associated with Small Cell Forum for a little over 7 years. I'm happy to be part of this elite panel. Thank you.
Yeah, thanks, Keyur. Peter?
Yes, so Peter Claydon, I'm president of Picocom. Picocom's an independent semiconductor company, and we've developed solutions specifically for Open RAN and for small cells.
Welcome, Peter. Roger?
Hi, I'm Roger Galuban. I'm a product manager at Ericsson, looking after our small cells portfolio, more specifically in the in-building segment, where we've been doing a lot of work with the not just our service providers that we've been working with traditionally for decades, but now also with neutral host companies, where there's been quite a bit of interest in modernizing buildings with solutions in that space. So very happy to be a part of the panel today with all of you.
You're welcome, Roger. George?
George Aguilera with Crown Castle. I'm a systems architect, a person working in the area of technology strategy for Crown Castle. We bring in newer technologies or updates to technologies into the company, and been involved with a Small Cell Forum for a couple of years now, and we look forward to all collaboration that we can get. So that's it.
Welcome, George. Yang?
Hi, my name is Yang Xu. Thanks for having me here. So I'm a connectivity technology and ecosystem manager of Meta Connectivities. So I work as the tech lead for the TIPS Open RAN small cell subgroup and also the TIPS subgroups. So as the TIPS Open RAN small cell subgroups, we promote and the 5G, the open small cell system based on the open interface and the architectures. Yeah. Happy to be a part of the panel discussion here. Yeah.
Thank you, everyone. Okay, so let me first start with you, Peter. So one of the questions that came in often, that we are seeing a lot of diversities in the Open RAN small cells with respect to the splits, power classes, spectrum. So what's your thoughts on addressing all these different diverse requirement, and at the same time we have to keep the cost low, since we are talking about the small cells solutions. So please, can you share your thoughts on this?
Yes, thank you. It is a challenge doing this because you're right, there are different splits, different functionalities required in different places. I think overall a lot of the early Open RAN solutions have been based on trying to use software right across the whole spectrum of functional units, including the PHY layer. Now that's proved something we have in our lab. We have huge servers that a lot of the cores in those servers, a lot of the resources are dedicated to PHY layer processing, which is inefficient. I think a lot of companies are now moving away from that for a lot of small cell deployments to something that's more optimized. And as soon as you go to silicon, which is more optimized for the purpose, you get some huge gains there in power saving and being able to do things for a far lower price point. And then within that, it's the right mixture of what you actually do in hardware assistance, actually really in hardware, what you do in maybe some slightly configurable sort of DSP processors, and then what you do in general purpose processors. And if you get that split correctly, you can then scale across different sorts of base station, maybe going from 2, 4, 8 antennas, different bandwidths and so on. But there is a challenge to do that, and particularly when you're looking at the RU, whether that's a split, a small cell 4 and split 6 RU or a split 7.2 RU, you're facing some challenges there. But there are a number of, the good news is there are a number of semiconductor companies coming along now who are addressing this with silicon that's designed specifically for the purpose.
Oh, that's nice. Any thoughts, Eugina, you have on the topic with respect to the various requirements in terms of the split power class and the spectrum, and how do we address those, keeping the cost low?
I think it's a really great question, and Peter addressed it from the technology standpoint. I'm going to address it from the business standpoint. what are the use cases that we need those power outputs and splits? Because for some of the splits, for example, 7.2, it requires an additional server. So that is an additional cost. Split 6 with Unfapi might bring less power output for a particular use case, but the cost will be less. So the technology aspect of a small cell or a macro or what split to use needs to support a particular business case.
Yeah, that's good to know. So maybe I have one more question to you, Eugina. There is a thought behind it that the Open RAN invoke the additional operational complexities and provisioning as a network as a whole. So some analysis says that the cost of saving may be marginal. So what's your thoughts on this issue that the Open RAN having the solutions from the different vendors, where does it make sense?
So how long do we have? We have only 30 minutes. It's a joke. It's a, and I made you, all of you laugh. So I think to shorten my answer, if we look at the legacy deployments, there are 3 options to integrate. One is with the mobile operator itself. Second one is with the system integrator. And the third one is with the hardware or software vendor. None of those models change in the new Open RAN world. So the complexity will come originally from having multi-components from different vendors. And if we look at how the ecosystem evolved in just the last 3 years, we went from about 5 vendors in the RAN space to over 50 and 60, if we count all the small cell vendors. So organizations like TIP, Young is representing TIP here, and Small Cell Forum, they're making sure that the initial integration creates blueprints that can be deployed. So that complexity goes away. And the second one can be addressed with all the new components that Oran Alliance introduces, non-real-time RIG and near real-time RIG, because with artificial intelligence and machine learning, the configuration can be automated, but also the optimization. So I'm going to turn it around, this question, a little bit and say, when people mention that Open RAN integration is complex, why are they doing it? What is their motivation? Because Open RAN is nothing less and nothing more than innovation in our industry.
Yeah, that makes a lot of sense. And I think you have already answered part of my next question, that how do we reduce the complexities of integrating the multi-vendors open network? You talk about the blueprints. Any other thoughts do you have in your mind which can reduce this complexity?
I would give the stage to Ying because TIP is doing a lot of good work in their labs. So, and they have some really good examples through their Plugfest, how they are able to reduce that complexity. So Yang, the floor is all yours.
Yes,
sure.
Yang,
Thanks. Thanks for passing this question to me. So as we know, so TIP is focused on productization to make the products ready for deployments. That's one of the TIP major thrusts is about to define and validate the blueprints, which is a compilation of products that's from multiple companies. Within the subgroup of small cells, we actually have been validated a couple of small cell blueprints for multiple companies through the lab trial, and recently we also completed one of the field trial with the China Unicom to validate the blueprints end-to-end in the field environment. That said, it's not so for the validated solutions, they will be awarded to the TIP badge listed on the TIP exchange. But more important, we will share the learning with the communities through the test plans, lab trial test plans, field trial test plans, then to the test result. The test result are going to include all the products configurations, and the result and the learnings, what's the pitfalls we should avoid. So that is why we try to the team is positioned to harden the solution from the deployment perspective. That's to reduce our integration complexity. And based on this open interface, it is the telecom industry has been doing this integration for a while. I think it's getting smoother and smoother. We have seen the integration happening in the lab without the vendors on-site support, and just with the tips engineers, we can do the integration and demonstrate performance. Yeah.
Yeah, that makes a lot of sense actually. Yang, I have like one more thoughts on you. That okay, in terms of the small cell you mentioned, but is there anything specific happening within the TIP community related to the private networks or the neutral host?
Yes, yeah. So as the TIP community is for private network, we look at the there's two domains. One is the public, the other is private. For private, we see a trend is this disaggregation of the hardware and software. Then in the middle, there's a virtualization platforms. I think that is one that's really decoupled the hardware from software and the private network. They can utilize this container platform to host this on the run side, and use some of the IT for the mobile edge computing as well. And this greatly reduced the complexities. What the couple of blueprints we validated all involve this container platform, either from VMware or Red Hat or other companies. So that is this would help to reduce our complexity, and as Eugina just mentioned, the automation part as well, for the run design to design and deployment automation.
Okay, thanks, Yang. So maybe I will next talk to Keyur. So Keyur, if we talk about the OEM vendors, so they sometimes pick some of the features to be implemented in their products, but then you deal with another kind of set of the people, which is like the customers. So which brings the business and the functional requirements to the table. So as a solution provider for the neutral host, so how do you bridge the gap between what you get it from one end and what the other end is asking from you?
Thank you, Vikas. I think this is a very timely and very relevant question. I'll just quickly step back and give a little bit of context and how neutral host operates and how the business model relates to the question you have. Right. So we are essentially designing, building, owning, and operating distributed networks for providing advanced mobile connectivity, both outdoor and indoor. And our solution portfolio spans across small cell, DAS, evolved packet core, fiber, and communication and building infrastructure. So in that assets, right, we play the role of a network infrastructure provider to our target customers, whether it is mobile network operators, whether it is enterprises, building owners, municipalities, right? So essentially, we are the network provider, and it includes all the various network components and network equipment that are required, right? So as a carrier of a carrier, the question really becomes that who owns the equipment, right? If the equipment is owned by the neutral host, then the responsibility to maintain the product roadmap, ensuring that features are there that our customer needs, lies on the neutral host. And that's what we are seeing, right? In traditional 3GPP fixed and mobile market, where we have a large customer base within the US, Extenet maintains the product roadmap. We work with the ecosystem partners, and we have a strategic portfolio of qualified vendors. We own the roadmap, we build the roadmap, we define the features, and we work with our suppliers to make sure that features are ready and available for our customers. What we have also seen is that, in the fixed and mobility markets, some of our service provider customers, they choose to take that ownership of just a RAN portion of the equipment. In that situation, they actually, they actually play this role of defining the features and working directly with the vendor so that all the features are supported. There are some open RAN suppliers in this market who have provided that capability. But I'll just take a few seconds that in the DAS space, what we are seeing is that the service providers are actually selecting the open RAN vendors, and they put the responsibility in the DAS vendors to make sure that the open RAN RUDUC works appropriately with that DAS solution. But I think when time comes, if neutral host is going to own the open RAN equipment as well, then we will own that roadmap, ensuring that the interoperability is there and the features are already available.
Yeah,
Hopefully that answers the question.
Yeah, very insightful. Thank you. Roger, any thoughts on the same topic from your side?
Yeah, absolutely. No, I think Keyur's answer is right on, right? So what we have observed in discussing with partners such as Extenet, Crown, and others who are sort of sitting between the venue owner and customers, right? And us equipment providers, and bringing all that together with requirements from CSPs, is that often the CSPs will have a very established way of working and very specific targets on the experience and KPIs they want to provide in different venues. So if you talk about a stadium or an airport where they have a particular set of KPIs they're trying to meet, there are some technologies that must be there. And as I think we all can acknowledge where we are today, there is no waiting for 5G, right? 5G is moving at a very fast pace. So we're I think learning a lot, and will continue to evolve and make significant progress as an industry in opening up interfaces. But when you talk about deploying the next major airport or stadium, we have to use the solutions that are here. And these solutions, they have to be built in a certain way that will allow us to coexist with Open RAN as it's being added as part of that infrastructure over time, right? So I think that that's a key requirement from CSPs that we're hearing today, is that any small cell solution we deliver, neutral host applications, or even not, they must be capable of operating today with the, let's say, purpose-built hardware, but also provide the openness of on the architecture interfaces to disaggregate, bringing things into a cloud with management, and of course with standard interfaces. Does that make sense?
Yeah, that makes sense. Thanks, Roger. Let me talk to you, George. My thoughts on you is that Roger talked about where the Open RAN and the private networks plays a role. So in your opinion, what is the best fit where the multi-vendor Open RAN in terms of the cost and complexities is the best fit? So is this best fit for the very large enterprise kind of setup, or it is also makes sense for the small and the medium kind of the businesses? So what is the best fit for it?
It's a very good question, and I think that drives we take it from the perspective of the business, and in my opinion, Open RAN is not even on the table until it becomes, it comes as a potential solution. So we go by the requirements first, and if it makes sense to go with a different split for a certain customer, then for a certain architecture, let's say, because we're a neutral host provider and we have certain assets that we can share. They could be local POPs, they could be edge data centers. We can have some assets on the premises. And so as I see it, Open RAN can work for private networks in conjunction with neutral hosting for multiple mobile operators. It does require more physical plant, more fiber, and compute resources. So there's more to manage and also deploy, and not only manage, but also manage over the life cycle. And so it may not be a good fit if it's a purely private network, for example, but it may be a better fit if it's an MNO. However, if it's a large private network, maybe a medium, not small to medium, but medium to large, maybe that makes more sense depending on their capabilities in-house as well that we can share.
That makes sense. Any thoughts, Eugina, on the same topic from your side?
Thank you. So I would like to bring a couple of things here. So number one is Open RAN is not a fancy technology. Open RAN is open interfaces. So if it's easy to integrate regular RAN, legacy RAN, whatever you want to call it, then it shouldn't be as complex to integrate Open RAN, because it's the same radio components, it's the same servers, it's the same software. It just comes from the ecosystem of vendors, and then you can build the best of breed RAN. So that's number one. And number two, I want to build on what George was saying. You always need to think as a solution provider, how you're going to help that business to be more productive or more efficient. Why open RAN for private networks, for private 4G or 5G? Because it's going to connect not only people, it's going to connect things as well, and it's going to deliver the productivity and efficiencies that current solutions like Wi-Fi don't deliver to the enterprises. So it's, for us, it always starts how I'm going to support the end customer that's going to be using this solution, and how I am as a solution provider going to improve their business.
Yeah, thank you. Roger, maybe I have one question to you, that as a consumer to the neutral host and the private network, is there any convenient way to know that the readiness of the certain specification, or how as a solution user, they will know that, okay, this can be achieved by the neutral host and this cannot be achieved? Is there some simplified way to know that?
Sure, and I think I'll actually go back to Eugina's point, which I thought was a great point. You have to start with the solution in mind, and how are we going to help that particular venue or enterprise, right? If it's a private network or a neutral host application. And to be frank, we're hearing from a number of enterprises that are looking to deploy a private network to do both. And they're saying, by the way, my coverage is not great. Can you help me? In addition to the private network, also deliver to me a neutral host solution. So not only my employees, but my clients and visitors, as they come into my site, they can continue to have a good experience as they have outdoors. So you know, I know that sometimes we like to separate the two buckets, but we're hearing that they're looking for solutions that address both. So when we talk about neutral host and of course being based in the US, I'll talk a little bit about the US scenario, and then of course we can expand that globally. But we see a situation where the evolution to open interfaces and cloudification of the RAN is happening at a different speed for the different operators, right? That's just a reality. So when I'm going to deploy a neutral host solution, it's difficult in today's world to say I'm going to deploy an Open RAN stack if the signal coming from the MNO is not ready to support that yet, right? Because they haven't modernized. So I think before we're even ready to talk about the interfaces and what to use, I think we need to work in motivating the industry towards that evolution and the benefits of moving a lot of the RAN processing to a centralized way and being able to have that evolution happen. And as we know, it takes time. Some of these very large CSPs or service providers move at a pace that has to take into account the very large install base of networks that they have, and they have spent billions of dollars in going from all the Gs all the way to 5G today. So it will take some time. So I think from a neutral host perspective, to be cost effective, it will certainly happen, but it will be at a time where all the CSPs in that particular market will be ready to embrace that, right? So because a neutral host function, if I have 1 out of 3, say, service providers that are not ready, it just, my solution doesn't work, no longer becomes cost effective, right? If I have to deploy 2 or 3 separate systems. So that's what we're seeing. But let's say a few years down the road, I can certainly see us deploying networks that are disaggregated, and you have private and neutral host functions being able to totally support it on the same ORU and ODU, some of them on-premise, some of them maybe centralized in the metro area.
Thank you, Roger. Peter, any thoughts on the same topic from you? You seems to be on mute, Peter. please.
Thank you very much. Yes, and a point is, I think Open RAN, as going back to Eugina's point, is that actually doesn't necessarily mean centralized. It means open interfaces, and I think that provides more flexibility. And looking at this, the 50 vendors, or how many we now have, particularly in the small cell area. I think when we look at those, they're all becoming based on the same underlying technology. And one is there are relatively few chip providers. So a lot of the solutions are built on, they may look, they're very diverse, but they're based on a smaller number of fundamental things. And the other is test equipment. There are a small number of test equipment companies, Keysight, VRV, and so on, and that everyone is testing against the same test equipment, and they're testing those interfaces. So I think this is, and what we're seeing in the market is that there's quite a rapid movement, not necessarily equipment that's in the market today, but equipment will be in the market in next year or the year after. That's really adopting these Open RAN interfaces and supporting, FAPI, Open Front Haul in particular. And I think when we see the RIC and that sort of centralized management, coming along, being more standardized, it will see an enormous expansion of the adoption of Open RAN.
Thanks, Peter. And time just fly. I have one more question. We have seen about the technology readiness to where we stand today, but there are few deployment which has already been happened. So I like to ask George that what are the challenges that you see while deploying the private network in those initial stages, and what are the learnings that you have that you like to share?
Well, definitely, not only for private, but also for the operators, putting it together makes it more complicated. However, there's a certain expectation of performance that we need to provide the same performance that we used to have. And we also need to provide the KPIs and counters, or us manage them, or us share them to the right people for their business needs. So the right set for the right business for the solution, it probably won't be a one size fits all, but the customer, whoever the customer is on either end, if it's the MNO or if it's a private network operator, they all want to know how their network is running at any time. And there's going to be SLAs, during the life cycle of the network, and those need to be kept and maintained. And of course, we don't want to be penalized for anything. So we have to be able to provide the redundancy that's needed, and the consistent performance. So those are major, besides complexity and all those other things, those that we had to overcome, because we've got to be able to manage what goes where. I think the keys are still in performance and the KPIs that represent the performance.
Thanks, George. Keyur, any thoughts from your side related to challenges that you see in the deployment?
Private networks, yeah, absolutely. So, we are seeing quite a few opportunities actually in both sports and entertainment and hospitality segment, and even industrial manufacturing segment with private networks. And like what George said, I think the opportunity or the challenge here is ensuring that the underlying network supports the KPIs that the customers need. They expect this to be a carrier grade network, right? Our private, the venues or the enterprise, they are relying on the connectivity for critical services for their customers. So they need a partner who understands the network performance requirements, who can deliver the carrier grade connectivity. But at the end of the day, they want one throat to choke, one person to contact, to work with all the different vendor solution providers and ensure that their investment is future ready. So in that sense, I think the neutral host business model is very suitable for private network providers, for somebody to take the full ownership and operations of the network, which they don't really are. They're not equipped today to manage the network. That's why I think those are similar opportunities what George said, and I think I totally agree with his comments so far. Thank you.
Roger, any thoughts from your side?
I couldn't agree more with George and Keyur on this, right? I think the challenges of KPIs, performance, future-proofness, which both of them made very, very clear, are table stakes, and how our MNOs and private networks want to run their business, and we must keep that as a front and center for every project that we work on with our partners or directly with the MNOs. The investment to bring a 4G or 4G plus 5G deployment now in these venues is obviously significant, and being able to understand that investment will be there for years to come, to delivering capacity and maybe growing capacity as needed without having to go and do a rip and replace because the technology that was deployed couldn't meet the needs. I think that's absolutely key. And I'll just add a little bit to what George said. I think on the visibility aspect, right? Venue owners, private network operators, clients, sometimes even enterprises in a multi-tenant building, if they're running specific services or applications, maybe it's on an edge computer or something, they need visibility of what is happening within their network, right? And this is something we've been learning over the last couple of years as we are actually deploying neutral host small cells out there. So this is a reality, and we must be able to help folks such as Extenet and Crown who are deploying these networks using equipment from vendors such as Ericsson, Parallel Wireless, and others, that the visibility to these clients are critical, right? So they must know, just like they see in Wi-Fi, well, my phone is not working, or I need this particular small cell went bad, or there's a connectivity problem in the backhaul. What's going on? How do I get myself back online, right? So these sort of basic questions that we are used to answering for decades now in the cellular world, working with MNOs. Now, those similar questions are brought into the space of private networks and neutral host networks. So this is one area where we'll continue to I think, evolve as an industry, making sure that we address all of these needs from enterprises and venue owners as well.
Thanks a lot, Roger. That was very insightful. So maybe this is the last question to all of you, that where do you see or conclude in terms of the neutral host and the open RAN plays a role in the 5G deployment in, let's say, 1 year to 5 to 7 years time frame? Yang, your thoughts on that?
Okay, yeah. I think it's as we can see from the operators' requirements, like so for example, the G5 operators on Europeans, the RAN sharing is a must for this kind of small cell deployments. It's not only from technology perspective, it is more from this zoning and the permit technology perspective. It's hard to imagine as in a venue you can build a parallel network from different operators. So the requirements is there and all the needs are there. I think Open RAN is as a technology just being able the sharing this neutral host as a provide perfect platform. Yeah, as we know, it's with this container platform, you can easily put different container apps. We see use from different operators on the same hardware sharing platform. Yeah,
makes sense.
And we see
George?
that's the big trend to go. Yeah.
George, your thoughts, concluding remarks?
Yes, I think that so in the next few years, solutions with Open RAN, especially openness is important, and those are going to be more fully baked. There's going to be more flexibility, and we as consumers of like Extenet and Crown Castle, consumers of the future networks that we want to project down for a long term, we want that openness and that flexibility, as well as the other performance factors that to come into place. And I think there are going to be more solutions available, or at least more platforms that are flexible enough, to permit different maybe mixes of splits and also different kinds of equipment. So, so that you have different requirements in different areas with the same customer site, if you will. And, we want that flexibility so that we can make it as cost effective as possible and also provide the right solution to the customers.
Thanks, George. Peter, your thoughts?
I think it's certainly the case that we've had a first generation of Open RAN solutions, and these have had their limitations. They haven't necessarily been that open, high power consumption, and really at the wrong price point. What we're seeing now is that for the generation that's coming, those issues have been addressed and allowing a lot of flexibility. And part of the issue is how the rest of the ecosystem is going to use that flexibility. There are neutral host operators who can take equipment and deploy it. But I think there is that point about mobile operators, all being at different stages of development, having different requirements. And that's probably one of the major challenges.
Thanks, Peter. Keyur, your thoughts?
Yeah, so I think we are seeing that the deployment of neutral host and 5G is happening today. We did not wait, but it has started already. As far as the deployment of Open RAN goes, we as a neutral host see that it may take a little bit more time to mature in terms of making sure that it is ready for MNO service KPIs, and it is a turnkey product available from a system end-to-end system integration point of view. So when that is ready, we need to be prepared. And at the end of the day, the opportunity for neutral hosts is to provide best-in-class TCO to reduce the barriers and open new market opportunities. So for that reason, as I said before, we need to build future-ready network, and Open RAN, Cloud RAN, these are key technologies that we have to design today. So I think the time is right to partner, and then that will help us provide best TCO for future deployments. Thank you.
Thanks, Keyur. Roger, your thoughts?
Yeah, so I think my colleagues have covered it quite well. I think if we look down the road, right, say 5 years or so, we will see a greater and greater inclusion of Open RAN as a solution. And I really like what Yang said about the sharing piece, right? Because I think one of the big challenges we have as an industry, if we acknowledge that more and more we need 5G, and 5 years from now, maybe we're start more and more talking about 6G, right? And there are more and more buildings, more and more venues that need that capacity. The CapEx is still limited. How do we accelerate that? Right? And sharing has to be one of the answers. There's no question in my mind that, in the past, maybe we only shared antennas, right? That's where desks were. So now we're looking at, let's share more of the radio. And then further down, let's share more of the RAN. I mean, we're moving from the antenna towards the core more and more. And that evolution is certainly before us for the next few years. I think we must work with our colleagues and Crown, Extenet, and others who are putting the entire package together for venues to make sure that the products that we provide are flexible enough, not only to enable them to accelerate the 5G deployments that are happening right now, that can address the MNO requirements as they shared, but also provide future-proof evolution as Open RAN is concerned, whether it's the addition of the first switched front haul and some of those radios, and then more and more open interfaces. This is a must-have, and I think we'll be sitting here maybe 5 years from now and see, yep, that's the target we're hitting. But what happens between is a time where there's going to be some hybrid, at least that's my perspective, solution, right? Where there will be some purpose-built hardware that's still going to be there in the legacy networks that have been built, and you'll start adding more and more of the open interfaces. So the equipment that is being deployed today and in the next couple of years, we have to think about this. How do we support that hybrid environment? As some CSPs want to move faster, maybe some a little bit slower, but the networks of the future, we're building them today, and let's make sure that we're ready to deliver those solutions in a good way.
Thanks, Roger. Sorry, Eugina, to keep you waited. Please, your thoughts. You are on mute.
That's okay. We saved the best for last.
Yes, that's why I saved you.
So I want to comment on what Roger said. We cannot hope that if we build, that they will come. So the next year, just like with Open RAN put mobile operators in the driver's seat. Private networks will put enterprises in the driver's seat. And enterprises, they don't care if it's neutral host, if it's cloud-based, if it's whatever technology. All they care that it's going to meet their business needs. And it's a surprise that many of enterprises, especially in the US, they take their destiny in their own hands. For example, John Deere bought a whole bunch of CBRS spectrum. So what we will see in the next year is the solutions will be driven by the spectrum that is available for enterprises, also needs that enterprises outlined in their RFPs, RFIs, or by meeting with solution partners. And number 3 is the skill set that the enterprises have in-house. Because Open RAN, it's not just open interfaces, but it's also softwareization of the infrastructure.
Thank you, Eugina. You have a very good thoughts as a concluding remark. So it was my privilege to talk to you, all of you, and lot of insights into it. We can talk more and more, but time limits is there. So thank you, everyone. It was a pleasure talking to you all. Thank you.
Thank you.
Thank you.
Thank you all.
Thank you.
Thank you so much. Thanks, Vikas.